Again, in this example, our radical is already isolated on the left side. So step one is to work at eliminating or removing the radical sign. And we do this by raising both sides of the equation to the power of the index. In this case, it's a square root, so we're going to square both sides. That gives me negative 7x minus 12 equals x squared. And just like in the last example, we now see we have a quadratic. So I want to move things from the left side to the right side, which will result in my a x squared still being positive, just as mentioned before. So ax squared plus bx plus c is what I need alone on one side of the equal sign. So I'm going to leave my x squared where it is. I'm going to move the negative 7x to the other side. That's going to give me a positive 7x because I'm moving from side to side. And my negative 12 from the left side to the right side is going to give me a positive 12 because I moved from one side of the equal sign to the other. So now I have an equation of x squared plus 7x plus 12 equals 0. Solving that quadratic, the easiest way to solve would be to factor. So when I set up my factors, I know I'm going to have x and x, and now I need to list my possibilities for 12. So I can get 1 times 12, 2 times 6, 3 times 4, or I could possibly have negative 1 times negative 12, negative 2 times negative 6, or negative 3 times negative 4. Those are my possible factor pairs. I need the pair that will add up to 7. So I see I want to use the 3 and the 4. So I get x plus 3, and I get x plus 4. Next step towards solving still is to split it up using the zero product property. Either x plus 3 equals 0 or x plus 4 equals 0. When I continue to solve this, I need to get x alone, so inverse operations. I have a possible x equaling negative 3, and in this case, minus 4 from both sides. The other possibility is x equals negative 4. Before I commit to my answers, I need to check, plug them in and check. So I have to go back and make sure. So I have negative 7x minus 12 is what I'm supposed to have under my radical. So negative 7x minus 12. And we're claiming that that is going to be equal to x. So when I plug in, I'll try the x first. The first one is x equals negative 3 first. So when I plug that in, I'm going to have negative 7 is 12. When I plug in negative 3, what do I get? So in this case, I will get square root of a positive 21 minus 12 equal to negative 3. So that's going to mean 21 minus 12 is 9. The square root of 9 is 3, and 3 does not equal negative 3. So this is considered extraneous. In the second case, possibly negative 4 might work. So I'm going to plug in negative 4 everywhere I see x. Try evaluating that. Negative 7 minus 4 times a negative 4, is positive 28 minus 12. 28 minus 12, 16. The square root of 16 is 4. But what did we want it to equal? Well, it says negative 4. 4 is not equal to negative 4. So in this case, they're both extraneous solutions. Keep in mind that sometimes both will work, sometimes only one will work, and sometimes both won't work.